Hello everyone. In this video I wanted to go over a few example problems in dealing with calculating out the force of friction and the coefficient of friction. First example problem. A baseball player with a mass of 78 kilograms slides into second base, is retarded by a frictional force of magnitude 450 newtons. What is the coefficient of kinetic friction between the player and the ground? This problem is pretty straightforward. If the only trick is that we need to make sure that we convert the mass of the object to a weight, and assuming that it's on a level surface, which usually a baseball field is, then this force here, the 774 newtons of the weight, is equal to the normal force. So we know what the normal force is. We're told what the force of friction is, 450, so we're just looking for the coefficient of friction. So we just plug the values in, divide 450 by 774, and we get the coefficient of kinetic friction to be equal to 5.8. Please notice I've only given you two sig figs here, and that's typically what's done with coefficients of frictions. You don't give any more than that. Second problem is a hockey puck that has a mass of 110 grams, is sliding over ice and stopped in 16 meters by the frictional force from the ice. If the initial speed is 6 meters per second, what is the magnitude of the frictional force? And part B is what is the coefficient of friction between the puck and the ice? Well, again, in drawing out the picture of this, we have the normal force upward, the weight of the object downward, and the frictional force acting in the opposite to the direction of motion. So with this problem, what we kind of have to determine is what is the net force acting on the object. Well, the normal force and the weight of the object balance each other out, and therefore the only force left over is the force of friction. So this is a problem in which the net force that acts on the hockey puck is equal to the frictional force. So if we could figure out the mass, oh wait a minute, we've done that already, we know that it was given a problem. So we need to figure out what the acceleration of the object is. And to do that, we're going to go back to the kinematic equations. And I'm looking at the third one down on this list, the final velocity squared equals the initial velocity squared plus 2a delta x. We know what the final velocity is, we know what the initial velocity is, we know how long it takes, probably not how long, how far it takes for it to stop, so the only thing we don't know in that equation is the acceleration. So in solving for the acceleration, the 6 meters per second squared divided by 2 times 16 meters gives you an acceleration of 1.125 meters per second. We know what the mass of the object is, and therefore we multiply that by its acceleration, and we know what the force of friction is. It's 0.124 newtons. Part B asks for the coefficient of friction, and because we've just solved for the force of friction, that from the part A, and we know what the normal force is, again, if we go back to the drawing here, the normal force and the weight of the object have to balance each other out because it's not accelerating upward or downward. Then we have the mass of the hockey puck multiplied by 9.8 meters per second, and thus the coefficient of friction ends up being 0.11. Hope this was helpful. Thanks for watching.